Hi everybody, myself is Fatima Maryam Najim of TKM College of Engineering, Kollam. Today I'd like to explain to you the working of monostable multivibrator using operation amplifier 741. You know what monostables are? Monostables are electronic circuits that produces a single timed output rectangular output pulse when triggered. Monostable multivibrator is also called one-shot multivibrator. They are positive feedback or regenerative switching circuits that have one stable state and one quasi-stable, that is astable state. An external trigger signal is applied for it to change its state, and after a set period of time, that may be either in microseconds, milliseconds or seconds, which is determined by the RC components, the monostable multivibrator returns back to its original stable state where it remains until another external trigger arrives. This is the circuit diagram of monostable multivibrator. It consists of operation amplifier 741. The op-amp has an inverting terminal and a non-inverting terminal, and output is taken from here. Consider the instant at which the output voltage VO is positive Vsat. Now the diode D1 clamps the capacitor voltage at 0.7 volt. Feedback voltage available at the non-inverting terminal of the op-amp is positive beta Vsat. Beta is R2 by R1 plus R2. When the negative going trigger is applied such that the potential at the non-inverting terminal becomes less than 0.7 volt, the output switches to negative Vsat. Now the capacitor charges to negative Vsat through R because now the diode is reverse biased. When the capacitor voltage becomes more than negative Vsat, the comparator switches back to positive Vsat and the capacitor C is charged through R to positive Vsat until it reaches 0.7 volt. The time period of the monostable multivibrator is given by T is equal to RC ln 1 by 1 minus beta. We have said earlier beta equals R2 by R1 plus R2. Now let me demonstrate the circuit of monostable multivibrator. This is the circuit of monostable multivibrator assembled on the breadboard. This capacitor and this resistor forms the differentiator circuits, and the diode here eliminates the positive trigger from the differentiator and applies the negative trigger at the non-inverting terminal of the op-amp. This resistor and capacitor determines the time period of the monostable multivibrator, and this diode is used to clamp the capacitor voltage. As we have seen in the circuit diagram, this is resistor R1 and it is resistor R2. Now let us check the output of the circuit. Now let's check the output of monostable multivibrator. Output is taken from the 6th terminal of the op-amp, and in order to see the capacitor waveform, we should connect it in the 2nd terminal. This is the output of the monostable multivibrator. The yellow line shows the output waveform and the green line shows the capacitor output waveform. We have designed the circuit for a pulse width of 1 millisecond. Now let's check the pulse width using cursors. We have obtained a pulse width of approximately 1 millisecond. That's the end of the tutorial. Thank you for listening to me.